All right, so first, before we get into our activity for today, I want to just jump into the Canvas course and kind of just review where things are and what's available. We'll do that first. All right, so this is what you should be able to see when you go into the course for AP Stats. Remember, the page is kind of split in half. Once you get from the top there, we've got the calendar and the modules. All right, modules are organized by chapter, so we have all the chapter 6 stuff right here. Notice I've added a few things to the module, like for section 6.1. Right, I've got the practice problems from Pear Deck, and I also have the solutions for the Pear Deck. So if you're going back into that to get some practice, you can check your work. And then obviously there's the notes and things. I am starting to work on chapter 7. Notice there's prerequisites for chapter 7. I do want you to be able to self-pace and move forward and move through the chapters at your pace. However, you need to finish chapter 6 before you do chapter 7. So the only prerequisites is that you've submitted the multiple choice assessment and the free response question, right, for chapter 6. All right. So please, once you do that, these will be marked. You'll be able to get into the chapter 7 stuff. I'm starting to put all that stuff together for chapter 7. All right, and then remember the calendar is where you will find links to things that we've done in class and the live videos from our class recordings. Okay, so if you wanted to watch yesterday's class, you would just go over to the 19th, go to the period 3 recording, and this takes you right to the YouTube video. All right, we'll do the videos for today in here, and I'll also have a link for the activity that we're doing, similar to what we did last week with the Pear Deck activity linked in the calendar. All right, so this is kind of how the day-to-day things will be found in the calendar, and then the more general chapter things and resources will be found in the module. All right, real quick, looking at this, actually I'm going to look at this on the real module page or the full-size module page so we can look at that. The free response question assessment, self-assessment, look, it shows you what stage you're at in this, which is nice. The details, right, shows the free response questions that I've selected. There's 2 questions, and that's section 1, free response questions. You can do these all on a piece of paper, upload the file. You can do these in a document, right? You can do this on a piece of paper, put it into a Google Doc and share the Google Doc, however you want to do that. As far as how you submit it, right? The second section, again, all this is done within pieces of paper, documents, however you want to put this together is up to you, but it needs to have the 2 different sections, right? Free response questions and self-assessment and reflection. All right. You can choose your submission type, right? You can just type it into a text entry. You can upload a URL. So like if you're sharing a document through a link, that would be there. You can record yourself answering the questions if you really want to. That's media or a file. You can upload any type of file. If you're doing a file upload, remember, it will only allow you to upload a file. Right, so make sure that your file contains all the parts of your document. So if you're like scanning pieces of paper, make sure they get put into a single document. You can't just take a picture. You need to use an actual like scanning app on your phone so that it compiles it to a single file. Just keep that in mind if you're doing it that way. Right. So there's multiple ways that you can submit this rather than me just choosing one. That was why I went with an assignment rather than a quiz type format. So again, that's just a quick review of the change on this now that it is available. Is there any questions? Moving on to our activity today, we're going to do a Desmos activity. Some of it will be self-paced, some of it you will do in small groups in breakout rooms. We'll start with the self-paced part, but first what we're going to do to make this a little more organized for me and for you is we're going to, I'm in the right page, yeah. I'm going to put this link, or you can go to student.desmos.com and use this join code here in the chat. And this is going to add you to the classroom that I have set up for us in Desmos. So now, if I ever do an activity, I'll have it added to the classroom activities for your class period. You can go to the class in Desmos and find all the activities that I've used in class in that one location. And it also helps me keep a record of who in which class periods have or have not done the activities, because these activities go towards your participation and classwork grade, right? That 10% chunk of your grade, right? It's done during class. It's not expected to be done as homework. You just need to do the activities when you do them in class and you get credit. It's that simple. But this allows me to do a much easier accounting of that. And it's very simple for you guys to join. When you join the class, please use your school email and write and put your name in. Don't just use a different email that generates a different name for you that is not the name that I have on record for you. There are some students who did not get credit for participating in like Pear Deck because there's no name. They used one of their personal Gmail, and the name they put in is just like a letter. I don't know who it is. You can't get credit if I don't know who it is. So please use your school email and put your name in so that I know who's getting credit for what. It makes life easier. All right, so please join the class. All right. To begin, recall the following. All right. Again, we're dealing with section 6.2. And this has to do with transforming and combining random variables. Right. Adding or subtracting a constant a to a random variable increases or decreases the mean of the random variable by a, but does not affect the standard deviation or the shape, all right, of the probability distribution. Adding or subtracting will only change measures of center and location. Measures of spread and shape are not affected. Multiplying or dividing a random variable by a positive constant b multiplies or divides the mean of the random variable by b and the standard deviation by b, but again does not change the shape of the probability distribution. So multiplying or dividing changes both measures of center and location and measures of spread. All right, so that changes both. Adding, subtracting only changes measures of center. In most of the examples we'll see today, measures of center, or the only measures of center we're going to be using will be mean. We're not dealing with median. We're not dealing with location. We're not doing quartiles, percentiles, anything like that today. Just the mean. All right. And as far as measures of spread, we're going to be dealing with variance and standard deviation. If you have a linear transformation of a random variable, meaning you are adding or subtracting a constant a and multiplying and dividing by a constant b, then you can write the linear transformation of the random variable x in the form y equals a plus bx, right? Where a is the constant that you're adding or subtracting, and b is the constant that's being multiplied or divided. All right, so this is just a quick reminder of the main concepts that we took away from yesterday. Is there any questions before we get started? So then we're going to the first question, which someone already answered. So we have a report of National Center for Health and Statistics says that the height of a 20-year-old man chosen at random is a random variable h with mean 5.8 feet and standard deviation 0.24 feet. Find the mean and standard deviation of the height j of a randomly selected 20-year-old man in inches. There are 12 inches in a foot, just as a reminder. All right, so there's a transformation going on from h to j. You determine, are we adding, subtracting, multiplying, or dividing, and then do the appropriate thing to adjust the mean and standard deviation. Type in the values you have for the mean and standard deviation in the box, so you can say, mean equals 5. And standard deviation equals 2. I don't know. I'm making up numbers. Please don't use these as the answers. Once you have your values in here, hit submit and explain. This is where you type in your explanation. If you try to type in your explanation where you have the math response, it looks weird. It just doesn't type very friendly. All right. So please, let's start on this problem. Give you all a couple of minutes to work on it. If you have a question, please let me know. Alrighty. You can see many of you guys are working on this problem still. Let's see your responses of those who responded. Now, the type of transformation that's occurring here in this problem is a multiplication. We're multiplying by 12 because we're converting feet to inches. Every foot is 12 inches. All right. So in this case, because we're multiplying, that change affects the mean and the standard deviation. They both receive that multiplication. All right, so to convert the mean of 5.8 feet to the mean for inches, we simply multiply 5.8 by 12. All right, if you're dividing by 12, that is the incorrect procedure. We would divide by 12 if we were converting from inches back to feet. We multiply by 12 to go from feet to inches. All right, so 5.8 times 12, right, and we get 69.6 inches. All right, and then the standard deviation also receives the same treatment and is multiplied by 12, and we get 2.88 inches as the standard deviation. Are there any questions for the men's heights problem? So again, it's incredibly important in these problems you identify, am I adding, subtracting, am I multiplying, dividing, and then give the appropriate treatment to each of the measures that you're working with depending on the random variable. All right. So again, you needed to be multiplying by 12. If you are dividing, that is the incorrect procedure. All right. We're going to jump to the next problem right now. All right. Everyone's moving to the next one. If you completed that last problem or not, don't worry, it's totally fine. All right, so this problem, we're going to be using the same context for the next 3 screens, right, about skee ball. All right, Anna is a dedicated skee ball player. If you haven't played skee ball, it's at like family fun center type of places where you like throw the ball up the ramp and try to get it in the hole. You get points for different holes that you get it into here. All right, Anna always rolls for the 50-point slot. All right, the probability distribution of Anna's score X on a single roll of the ball is shown below. And we have our score and probability here. You can check that the mean equals to 23.8 and the standard deviation is 12.63. If you'd like to check that, you're more than welcome to. You don't have to. It is provided information to use. Right, a player receives 1 ticket from the game for every 10 points scored. Make a graph of the probability distribution for the random variable t equaling the number of tickets Anna gets on a randomly selected throw, and then describe the shape. I do recommend, if you want, you can use the pencil here, right, and you can scribble around with your mouse. Or I think using the line tool is a little bit easier in this case, right? So for example, right, 1 is going to be right here in the middle. I'm going to kind of go around 1. We'll draw a line up to about 0.32, go over, and down. If it's perfect, no worries. If it doesn't need to be perfect, try to roughly draw it so you end up with the correct shape once you're done. All right, So again, I'm gonna give you a few minutes here to draw your histogram. Remember, this is a histogram. It is not a bar graph. There is special order to the x-axis and the order in which things go. So your bars should be touching. Alrighty. So if you were successful with this, which hopefully you were, you should have a histogram that looks kind of like a staircase going down from left to right. All right, so this would be skewed to the right as far as the shape. All right, it has a peak at 1 with probability of 0.32 and slopes down from there. All right, we can say the center is probably around 2, maybe to the right of 2 just a little bit. Doesn't appear to have any outliers. All right, we can say some things just about the shape and what it looks like in the distribution. All right. Is there any questions about what this histogram should look like? Based on what I see in you guys' responses, many of you got this correct and it looks good. All right. So we're gonna go to the next problem. Next part of this problem, we have the same context. All right, and again, we're talking about tickets, number of tickets Anna gets on a randomly selected throw, and our ticket, the possible values for T go from 1 to 5 based on the possible scores, 10 to 50. All right, and so we just need to complete the table, right? Find the mean. So again, you'll type in the mean on the table. You can just type right into the table here by clicking into it. Put in whatever you think the mean is. Once you've entered your mean, hit submit and explain. You can explain your thinking here. All right, and when it says interpret in context, that's what I would like in the explain your thinking. What does that mean? Tell us. Right? So there we go. I deleted too much. So give you a couple minutes here to work with this problem, and remember, we're doing a transformation that involves dividing by 10. All right, so in our table, you should essentially get the same exact probabilities as the first table. Right, the probability of scoring a 10 is 0.32, so the probability of getting one ticket is also 0.32. Probability of scoring 20 is 0.27. The probability of getting 2 tickets is 0.27. The probabilities simply transfer over to the number of tickets that go along with that score. All right. In this example, we are dividing by 10, right, to go from score to number of tickets. So that transformation says, well, to go from the mean of x to the mean of t, I divide by 10. So we take 23.8 divide by 10, and we get 2.38 as the mean of t. All right. So in context, that means that over many rolls, Anna can expect to get about 2.38 tickets per roll. That's what this means. That's how it's interpreted into context. All right. So are there any questions about this problem on the transformation that we just did and the context? We'll move on to the last part of the skee ball problem. Same concept, same things going on here, still dealing with the same two random variables of x and t. In this problem, we're now finding the standard deviation of t. So again, find what you believe is a standard deviation, type it in here, hit submit and explain, and then once again, the explanation I want is, what does this mean in context? Right, what does this mean about the variance that Anna can expect? All right. I'll give you all a couple minutes here to solve this one. Alrighty. So the standard deviation of t, right? Standard deviation for the number of tickets Anna gets on a randomly selected throw will be 1.263. Again, we get this by dividing the given standard deviation for x by 10. In context, this means that Anna can expect that essentially on a randomly selected roll that there will be a variance from the mean, which the mean is 2.38, of about 1.263 tickets. Right. So again, in this case, we just need to recognize that the process we should be doing, the transformation, is dividing by 10, which has an effect on the standard deviation. Had this been a transformation of just adding or subtracting, the standard deviation would stay the same. It would not be changed. Right, but because it's dividing, standard deviation is also divided. So any questions? All right. So then, next thing we're going to do, we have 3 more problems in this set of problems on Desmos. To do these problems, I'm going to set you guys into breakout rooms so that you can work collaboratively together. And we're only going to spend 10 minutes on these problems, so I suggest that you look at each of the problems, decide if you understand how to solve them, right? Discuss as a group how you could go about finding the solutions, right, for each of the 3 problems, and then try to actually solve them. Right, so the more important thing is to expose yourself to the 3 problems, decide as a group if you can determine how to solve them. Right, so then at the end of the 10 minutes, if there's questions, if you don't understand what you should even do to start, you can ask and I can help. All right, well, welcome back. We're going to quickly kind of talk about these problems and then we'll be done. All right, so for the first problem, making a profit, we are given a linear transformation, right, to go from the random variable x to the random variable y, right? And y essentially it is the amount of money that the firm retains, right? And it's given as y equals 0.9x minus 0.2. And we're using decimals of this because we're dealing with millions, and instead of writing all the zeros, we just use a decimal representation and say it's in millions. All right. So to find the mean, we use the entire linear transformation. All right. We use the whole thing. 0.9 times 3, the mean of the random variable x, minus 0.2. All right. And that gets us, where did I put the number? It's 2.5. All right, so we end up with 2.5 million, all right, for this example. Now, standard deviation is not affected by the minus 0.2, right? That's a subtraction, right, by a constant, has no change to the standard deviation. The only thing we need to consider is the multiplication. So to find the standard deviation of y, we only do the 0.9 times the standard deviation of x. Right, so we have 0.9 times 2.52. right? And we end up with 2.268 as the result. Okay. Is there any questions about this one? Right. The next question, right? The rainy days. This is about kind of understanding the concepts. So it's asking, is it reasonable to take the mean of the total rainfall x plus y to be the mean of x plus the mean of y? The answer is yes. Adding means, right, when we're combining two random variables, I can combine any two random variables I want, regardless of whatever else is coming next. When I combine two random variables and I want the mean of those two things, I always just add the means of those random variables. It does not matter if those variables are independent. All right. In this case, the recorded rainfall at the airport in Orlando and the recorded rainfall at Disney World, which is just outside Orlando, they are not independent. Right? But as far as means are concerned, it doesn't matter if they're independent. I can still add them, so it is reasonable. However, when it comes to the next part about variance, I can only add variances of random variables that are independent. In this case, our two random variables are not independent, so it is not reasonable to add the variances. Right? Because if I know that it's raining in the airport or at the airport, that has an influence on the probability that it's raining just outside Orlando at Disney World. That changes the probability, so they're not independent. Is there any questions about this one? Anything I can explain further? So again, to summarize, the condition of independence only has to be considered when trying to calculate probabilities, variances, standard deviations. The mean, I can always add. Right, and the final question, time and motion. All right, this is one of the scenarios where we're combining random variables and we're combining two normal random variables. All right, we're told that these can be considered to be independent random variables, so that helps. We can do things. And we also know from the lesson yesterday, when we combine two normal random variables, the result is also a normal random variable. So we can add the means to get the mean of the sum, and we can add the variances to get the variance of the sum, and then we can take the square root of that to get the standard deviation. Once we have the mean and standard deviation of our new random variable, which is the combination of our two random variables, then we can use table A to determine probabilities, standardize the score and things like that. So in this problem, what you should get, the mean of the sum of these two normal random variables, one representing getting a part from a bin to its position, the other representing the time required to attach that thing to the chassis. We get a mean of 31 seconds, and that's just 20 plus 11. And then we get a standard deviation of 4.47 seconds approximately. We get this by doing 2 squared plus 4 squared, the two standard deviations, but variance, right? 2 squared is the variance of the first one, 4 squared is the variance of the second one, right? We add that up, we get 20, take the square root of 20, we get about 4.47. Now that I have that, right, the distribution is normal with a mean of 31 and a standard deviation of 4.47 seconds. And then we use table A, I've got it linked here if you want to look at it. We're finding what's the probability that X is less than or equal to 30 seconds. We standardize 30, 30 minus 31 divided by 4.47, we get negative 0.22. We find that on table A, and we get a probability that Z is less than or equal to negative 0.22 of 0.4129. All right.